Hi everyone. So I'm really sorry about the technical issues that I've had before. I've started the stream a little bit early to make sure that everybody can see the screen okay. So can you just let me know in the chat whether or not you can see that screen and read the writing on it? That would be really handy. Thank you. I'm going to start in a few minutes. So, but yeah, if you could just let me know whether or not you could see that stream and see it okay, that would be really good. Okay, so hi. It's good to see you all. Hopefully this will go without any major problems. I did try to redo this stream. So last night's stream I did via YouTube. So a quick thing here. Yeah, last night's stream I did via YouTube, and YouTube decided that it was going to decide what my bitrate was, and it wasn't good enough to show the screen very well. So I have started using OBS Studio, which is quite a learning curve, even for me. It's quite technical in the fact that there's lots of little settings that you didn't even know that you need to have set. So hopefully this will clear up the problem with the screen being fuzzy from yesterday. And I did try to do basically a replay of last, not even 10 minutes, I think it was about 5 minutes in. My internet died. And it was because I use EE. And we've had a hell of a storm here, and basically, yeah, it went down, and the local cell tower, and there's only one, it went down for an hour and a half. So it's back up, obviously, because I'm back on the internet, but hopefully we won't have any problems. So thank you for bearing with me while I get used to streaming software. It's more complicated than you think. If you're not just talking to the camera, it's actually quite complicated to try and get it to do what you want it to do. Okay, so let's start, because that's what you're here for. Let's look at what we were doing yesterday, and I am going to go over what we did yesterday, because I think obviously a lot of you can't or couldn't have what am I trying to say? Yeah, I'm just going to go over what I did yesterday, because obviously you couldn't see a lot of it. Okay, so the first question for this exam paper was, binary is a number system used by computers, and tick one box to show which statement about the binary number system is correct. Is it base 1, base 2, base 10, or base 16? And this is base 2. It's base 2 because binary is a base 2 number system, which is based around the number 2. There's 2 digits, 0 and 1. Yeah, base 10 is denary, base 16 is hex. I don't know, I've never heard of base 1. They might have just, you know, made that up. Who knows? Yeah, if at any point you can't see the screen or something doesn't look right, just let me know in the chat. So the next question was, denary numbers are converted into binary numbers to be processed by a computer. Convert these 3 denary numbers into 8-bit binary numbers. So we've got 50, 102 and 221. So let's do those. I think this did actually show up last night in the thing, but I'm going to do it again just in case. So we've got 50, 102 and 221. Yeah, so someone's asked, is there a base 1 number system? I don't know. I don't think so, but if you want to look it up, you're very welcome and give us the answer. So I'm going to do the headings here. As you may well know, or maybe you don't, there is more than one way to convert between binary and denary, but we're going to just do the way that's the easiest without a calculator, because in the Cambridge exam you don't have a calculator. So for the number 50, we're going to have a 0 here because 50 is too small, or 1 to 8 is too small, or too big, sorry, to fit in, and 64 is too big to fit 50. So we can have a 32 though. So 32, and I am going to use my calculator, otherwise we will be here all day while I try and figure out all of this in my head. 50 minus 32 is 18. So we could put 16 on. So 18 minus 16 is 2. And 2 left over. So we've got a column for 2 and we can just put that there. Oh, so it turns out there is a system called unary. I didn't know that. Well done. Thank you. Fantastic. Okay, so that's 50. Let's do 102. So 1 to 8 is still too big, but we can have 64. And yeah, so we can have 102 minus 64, which is 38. We can have 32 on then, so 38 minus 32 is 6 left over. So 16 is too big for 6, 8 is too big for 6, but 4 isn't. So 6 minus 4 is 2, and we can have the 2 on there, and that's our 1. And then 221. So 221, we can have 128 on. So 221 minus 128 is 93. We could have 64 on, so 93 minus 64 is 29. So we can have, we can't have 32 on, but we could have 16 on. So 29 minus 16 is 13. And then 13 minus 8 is 5, is it? 5, yeah. So 4 plus 1 is 5. So that is our 221. And then I would just write that onto the exam paper, and you have working space for that. A good sanity check for this is to check the 1 column, and if it's a number it should be a 0, and if it's an odd number then it's going to be a 1 there. But just binary conversion, they don't often ask quite this many questions, but that's fine, we don't mind. We just have to go with what they ask. So let's look at the next question. The next question is doing negative number, so 2's complement. So I mentioned yesterday, you might remember, you might not, that there is sort of, yeah, when I teach this, a lot of students kind of want to know, when do I know whether or not it's 2's complement and when isn't it 2's complement? And the answer to that is they will explicitly say about 2's complement in the question. So this question here where we were just converting to denary, it didn't mention 2's complement, so just assume it's a positive integer, so a whole number. You don't have to deal with any partial numbers, decimal numbers, sorry, because that's A level. And it is quite complicated. It's second year A level, actually. It's that complicated, the way that computers have to handle numbers with a decimal place. Okay, so yeah, it does talk about 2's complement here. And basically we've got minus 78. It talks about binary being stored in registers. And we're going to put our answer here at the bottom in those boxes. And we're just going to convert minus 78, and we've got to show all our working. There's only 2 marks, so you get 1 mark for the right answer, 1 mark for all the working. So let's try that again. Minus 72. The first step is to remove the minus sign and make it a positive number. So we remove the minus sign, so that gives 2. The second stage is to convert to binary. So just a positive whole number, we're going to convert to binary. So 72, so it's 128, 64, 32. And we can see actually it's 8 bits because we've got 8 bits here on the exam paper. So 6, 4, 2 and 1. So a 0 there, a 1 there, 72 minus 64, that is 6, 7, 8. So we've got 8 there, is that right? Let me just check that. I should be able to remember this from last night. But 72 minus 64, yeah, it's 8. I doubt my mental maths. Okay, so my whiteboard is just struggling for a moment there. It does occasionally if my internet is not very good. So it comes back. It has come back. Good. I was looking at alternatives to EE when my internet went down this afternoon. I was like, Starlink is looking. I know Starlink's £75 a month, but I was getting very frustrated with it. Anyway, so that's 8. So we've got 8 left over. So that is our positive number in binary. So next thing that we do then is there's a couple of ways that you can do the next steps, and I've gone into my space there. The first thing that you do is you just double check this, because this 72 minus 6 is 8, and then there's 8. Yeah. Okay. I'm just maybe I did it with the least significant bit. So that's our least significant bit is always the number 1. The most significant bit, or MSB, is always the highest column that you've got. So we start with the least significant bit, LSB, and you write down, and you keep going until you hit the first one. So that's stage number 3. Hit the first one. So that's stage number 3. Oh, am I lagging a bit? Am I lagging? Am I lagging? I'm in Lag City, I think. Population me. Okay, I'll keep going. Yeah, I do seem to be lagging a bit. Yeah, I do seem to be lagging a bit. Okay, it looks like it's caught up, or it's catching up now. Okay, all right. So it's that's what I'm blaming it on. So we start with the least significant bit and we write down what I'm blaming it on. So we start with the least significant bit and we write down any zeros. So 0, 0. We hit the first one, which is this one here. So we write down any zeros until we hit the first one. And then the final stage is you write down that one, flip every bit. I've written down that one and then I flip every bit. So 0 becomes a 1 and a 1 becomes a 0. And that should be, oh good, you can hear me now, good. That should be minus 72. Now we can work out whether or not it's minus 72 by adding up the ones. So effectively this one here is minus 128. Is it lagging again? Oh, it's hopeless. It's hopeless. Okay, good. Okay, all right. You can still, you're a few seconds behind. Yeah, it is. I think it's about 10 or 15 seconds behind. Yeah, I'm just going to reload the screen because it looks like it's not got the capture. Let's try that again. I'm just going to... My speed test should be good. It doesn't seem to like it very much. I'm just going to check my speed test. Okay, so I think I'm back now. Can you hear me okay? I'm really sorry about this. I'm going to try and make sure I can get a really good signal or go somewhere where I've got a really good signal because it is very frustrating. I'm so sorry. speed test. Okay, so basically it is really behind. So I'm just going to carry on and assume that you can actually catch up with this. Okay, so the next question is two 8-bit binary numbers are given. Add the two 8-bit binary numbers using binary addition. Give your answer in binary. Show all your working. So for this question, I'm just going to write it down on the whiteboard. Otherwise, we're going to run into all sorts of problems. So I've got a 0, a 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 0, 1. Okay, so the rules are when we're adding binary that there's 4 rules. First rule is 0 plus 0 is 0 and 1 plus 0 is 1. And that's the same as denary. So you don't have to remember those two, you just need to know basic maths. But the third and the fourth rule, which is 1 plus 1, there's no 2 because it's binary, so we have to have a 0 and we carry the 1. And then the final one is 1 plus 1 plus 1, and that is a 1 and we carry the 1. So if we've got our binary here, we've got a 1 plus a 1, so we do each column at a time. So that's rule number 3, so that's a 0 and we carry the 1. And then we've got this column here, 1 plus 1, so that is another 0, carry the 1. And then we've got a 1 plus a 0 plus a 0, so that is just a 1. We've got 0 and 0, that is 0. 1 plus 0 is 1. 1 plus 1 is a 0 and we carry the 1. And then we've got 1 plus 0 plus 1, and that is a 0, carry the 1, and then a 1 on the end. So to get the full marks for this, you must make sure that you put those carries in. If you don't, then you won't get the full marks. So always just make sure that you put those carries in. So that's that question. Next question, 2 binary numbers are added by a computer and an overflow error occurs. Explain why the overflow error occurred. So what that basically means is, for example, we could have, if I adjust this here, I'm just going to adjust so that we've got a 1 and a 1 and we've carried the 1. So that means we've got rule number 4, 1 plus 1 plus 1. So that would be a 1 and we carry the 1, but we need to have an extra column. So that just isn't there. I mean, I know there's only 8 bits for this, but it would be sort of like a 32-bit computer or a 64-bit computer, and you've run out of physical components to hold that data. So that's what they're talking about. So we would say that the number is higher than 255, and therefore, the result is higher than 255. So you've basically run out of columns, basically, and you need to add another column. Now let's just have a quick look at the mark scheme. Always recommend you looking at the mark scheme. It's not cheating. It is just making sure that you know exactly what they're after, and you'll see the sorts of things that they're after. So here we have got the result of the calculation is greater than 255, or the value generated is larger than what can be stored in the register. So in this case, they're talking about registers, and registers are just binary stores used temporarily inside the computer. And then we've got the result of the calculation would require more than 8 bits. As I said, we've got 9 there, and a register has a predetermined number of bits. There are too many bits. Now, the bold in the mark scheme, basically that's their preferred term. You don't have to say a register has a predetermined number of bits, but that's what they prefer you to put. If it's essential, then it will be underlined and in bold. So just look for that when you are looking at mark schemes and think, well, that's the sort of terminology that they're really looking for. Okay, next question then is a student has a sound file that is too large to be stored on their external secondary storage device, sorry. The student compresses the sound file to make the file size smaller. The compression method used reduces the sample rate and the sample resolution of the sound file. State what is meant by the sample rate and the sample resolution. So again, if you were here yesterday, you hopefully can remember that, but the sample rate is how many samples per second. So the standard sort of rate is 44,100 for sort of CD quality or sort of really good quality music, 8,000 for low quality, and up to nearly 400,000 for good quality. Now, they're not asking that, but yeah, that's handy to know. So the sample rate there is the number of samples taken per second in samples taken per second or time unit. And then the sample resolution is just the number of bits that are used to store per sample. And it's normally 16, but again, they haven't asked that. It could be anything. In this case, yeah, it's just the sample resolution is the number of bits per sample. Okay, part B then says identify which type of compression has been used to compress the sound file. So we can see here it says they compress it, making it smaller by reducing the sample rate and sample resolution. So that is lossy. They're removing things. The sound file is transmitted across a network that uses packet switching. Identify two pieces of data that would be included in the header for each packet. So we did kind of go with this yesterday, but I'll do it again quickly. The packets have three parts to them: the header, the payload, and the trailer. And the header has the most useful information. The payload is just the data, and the trailer is just kind of like a marker to say it's the end. And it also has the checksum. So in the header, we've got the IP address of the sender. We've got the IP address of the receiver. And we've also got the packet number as well. So that's what they're looking for in this question. Any one of those three. There's only 2 marks though. So if you put too many, I mean, you're not going to get marked down, but you won't get more than 2 marks. So just 2 marks for that. And then explain how a file is transmitted using packet switching. So with packet switching, we have got, I'm going to go a bit quicker over this than I did yesterday, but over the internet, when we send data over the internet, it doesn't matter what it is, could be an email, could be a website, etc. All that we have is whatever we're sending broken down into different packets. Let's have a look. Someone's asked, do packets usually use checksum or do they use other forms of checking? It is normally a checksum, yeah. Yeah, in fact, you can see them if you have something like Wireshark, where you can capture packets going through a network, then you can see it tells you what the checksum is. Obviously, you need to make sure you use Wireshark legally, because it is illegal to use it on a network without permission. So just use it on your own network. So here is a packet. So we break down, you know, it could be a web page, etc. We break down the packet into the web page into different packets, and they get sent over the internet, and they could get sent to different routes. But it will always try and send it to the fastest route possible to the receiver. And the packets are set in the wrong order, but they're put together in the right order when they are received. So if we have a look at the marks, there's 5 marks for this. You only have to put bullet points. You don't have to write an essay. They don't give you any marks for good English. So all you have to do is just make sure that you have clearly stated what needs to be on the they're just looking for you to get those points there. So we've got the data is. Each packet could take a different route. A router controls the route path a packet takes, by selecting the shortest or the fastest route. Packets may arrive out of order. Once the last packet has arrived, if the packet is missing or corrupted, it is requested again. Okay, so that's the packet switching one. Next question, secondary storage devices are used to store data on a computer. Circle 3 components that are secondary storage devices. See if you can do this one. I can see that I am lagging quite a lot behind, so I'll give you a few moments to do it anyway. Which is secondary storage? If you were here yesterday, you might remember. So the three are the hard disk drive, a register, not a register, sorry, not a register, a hard disk drive, a solid state disk drive, and a compact disk. So those are the three things that are a secondary storage device. And then the next question is tick one box to show which statement about secondary storage is correct. And the answer is, drum roll, it's C, it's used to permanently store software and data files. Okay, so I think that is pretty much what we got up to yesterday. So we have got some time to do some more questions, which is good. So, oh yeah, we did this one. Here's the answers from yesterday that I did. I've left them on the here. So we did do this one yesterday, actually. So there we go. I'll just remove them. Or not. I might put them back, actually. We did this yesterday. Complete the statements about different types of software. So system software provides the services that the computer requires. An example is utility software. Application software is run on the operating system. The operating system is run on firmware, which is run on the hardware. So that's that question. Right, this is where we got to yesterday. And it's all about an automated drinking system for its animals. A drinking system has a water bowl that contains the water. When the water bowl is empty, it is automatically refilled. The system uses a sensor and a microprocessor. Identify the most appropriate sensor for this system. So what do you think that is? And then describe how the sensor and microprocessor are used to automatically refill the water bowl. And there's 6 marks for this, so it's quite unusual for them to do ones at this amount. And actually they have kind of moved away from these questions a little bit now. But see what you think. What sort of, how are you going to sort of describe how these things interact? How does the sensor and the microprocessor react? And I'll go through, I'll show you the answer in a minute, but just have a think about that. Okay, so identify the most appropriate sensor. The screen's a little bit fuzzy, but I think, can you still read the screen? Okay. Hopefully you can. So there's a couple of different sensors for this. And you could have a level sensor for the water, a pressure sensor or a moisture sensor. any of those three. And then to describe how these interact, it's fairly kind of formulaic, the way that these will interact. You would have a sensor continually sending digitized data to the microprocessor. I'll just make that a bit bigger. Oh, it's a little bit fuzzy. It's fading a little bit. It was going so well. It was going so well. All right, I'll read out the answer. So the question was, a farm has an automated drinking system for its animals. The drinking system has a water bowl that contains the water. When the water bowl is empty, it's automatically refilled. The system uses a sensor and a microprocessor, identifying the most appropriate sensor for the system. So it could be a level, a pressure, or a moisture sensor. And then describe how the sensor and the microprocessor that are used automatically refill the water bowl. So basically, the sensor continually sends digitized data to a microprocessor. The processor compares data to stored values. So that's basically like having an if statement, saying if the moisture sensor is too low, then it's outside the range. So we send a signal to release water to fill the bowl. The bowl is filled by a set amount or filled for a certain time, and an actuator is used to release the water. The whole process repeats until it's turned off or stopped. So, any kind of system question that they have like this, they have sort of moved away from them now. But yeah, it is very much a very formulaic answer. It doesn't really matter what the situation is. It could be any situation. It's just the sensor and the microprocessor talking to each other and an actuator that's moving. Okay, let's move on to the next question then. And the next one is, a user wants to connect their computer to a network. Identify the component in the computer that is needed to access a network. So identify the component in a computer that is needed to access a network. So it is a network card. So it's a network card or network. They've got network interface controller, NIC, or a WNIC, which is a Wi-Fi card. My screen, I'm looking at this, the screen from my iPad, and it's really, I can't actually read the text. Can you all read the text still? I'm going to assume that you can. I'll just read out the questions. Identify the type of address that is... You can read it fine. Okay, good. Identify the type of address that is allocated to the component by the manufacturer, which is used to uniquely identify the device. So this is the MAC address. So this is different to the IP address. The MAC address is the one that is given at manufacturer or by the manufacturer, and it is unique for every device on the internet. So the IP address is your location, and that changes wherever you are. I mean, you can get static IP addresses, but they don't. You have to pay extra, and they're normally dynamic, so they change. So a dynamic internet protocol address. I think I've just given the next question away. A dynamic internet protocol address is allocated to the computer when it's connected to the network. Identify the device on the network that can connect multiple devices and automatically assign them to an IP address. So what is automatically assigning an IP address? Well, it is a router that's doing that. You might have seen it on the mark scheme there. So the router does that. And then describe what is meant by a dynamic IP address. I've just given away the answer to that as well. Doesn't matter. So it's used to uniquely identify a device on the network. It can change. That's the main thing. It can change. And it changes each time the device is connected to the network. I mean, sometimes it doesn't change. So if it's at home, then chances are you'll probably just get the same IP address every time. But if you're on a big network with lots of people on it, then, or you go down to your local Starbucks or Costa Coffee or whatever it is, and you connect to their public Wi-Fi, they're going to give you a very different IP address every time because there's lots of people joining all the time. Okay, we've got time for more. Good. A programmer uses a low-level language to write a computer program for a vending machine. Describe what is meant by a low-level language. Now, you don't need to know how to program in low-level language. There's only 2 marks for this. Assembly language is a very well-known low-level language. And you're just kind of giving features of it, really. That's all they want you to do. So the main thing is with, you can give an example, though. So if you're ever asked to describe something, you could give an example. So you could say, for example, if I go back to here, with a low-level language, you could say STO for FA or something like that. And so if you have done some assembly language, you can do it. STO, that will just store a value in a register. So you could give an example. Or it's very similar to machine code or binary, and it's used in components. And these things here, like the STO, it's basically a type of what we call mnemonic. It's a silent M mnemonic. And it's just kind of binary commands that the computer will understand, but so you don't have to write a whole load of zeros and ones. It's been programmed, or the devices have been programmed to understand it. So let's have a look at the mark scheme. They have got in this, it's close to the language processed by computers, may use mnemonics. An example is assembly language or machine code. I mean, machine code is really binary anyway, so I'm not quite sure why they put that, but it doesn't really matter. Okay, let's we got time for a bit more. Let's do another. We can finish off this question. Give 2 reasons why the programmer would choose to write the computer program in a low-level language instead of a high-level language. Why do we use a low-level instead of a high-level? So for this, basically, we're talking, or they want you to kind of understand that low-level is used for components, usually for components talking to each other. You're putting together a vending machine and you want part of the vending machine that dispenses the items to talk to the keypad, and you would write it in low-level language. So it's that type of thing. So we can directly manipulate the hardware. There's no requirement for the program to be portable. So what that means is, if it's in sort of like an embedded device like a vending machine, you don't have to think, oh, is it Windows or is it a Mac? Well, it doesn't really matter because it's its own device. Also, though, if you are writing assembly language for something like assembly language is used for PCs. Well, you're getting the devices within that PC to talk to each other, and you're writing it specifically for a PC rather than a Mac, for example. The program will be more memory efficient. No requirement for a compiler or interpreter. They're quicker to execute and can be specialised hardware. Okay, let's do question 8. A manager at a company is concerned about a brute force attack on its employees. On its employee user accounts. Describe how a brute force attack can be used to gain access to the employee user accounts. So for this question, we're just thinking of 3 marks. What would happen for brute force? Well, they're going to write a computer program, and they're going to try the username or the password with different dictionary variations of words to try and get into the accounts, and try and see which ones work, or keep trying until they get in. So they've got trial and error to guess a password. Combinations are repeatedly entered until the correct password is found, and it can be carried out either manually or automatically by software. Well, I don't know whether anyone would really do it manually unless you physically have someone's computer and you're typing in trying to get in. But yeah, I suppose it could be the case that they've stolen a device and they're trying to get in that way. And then one possible aim for carrying out a brute force attack is to install malware onto the company network. State 2 other aims for carrying out a brute force attack to gain access to the employee user accounts. Well, there's lots of reasons why people do this, and they've got, interestingly, if you look at the mark scheme, it says EG. So that means if your answer isn't among this, it could be, it will be accepted. So they've got steal, view, access data, delete data, change data, lock account, encrypt data, damage reputation of a business, but also it could be political reasons, or, environmental reasons, or, whatever kind of thing, it could be all sorts of reasons why people want to get into it. Maybe some people are just interested, and they would have to give you a mark for that, because it's the truth. Some people do just hack because they just want to have a look around. And then give 2 security solutions that could be used to help prevent a brute force attack from being successful. So, a couple of things here. Definitely a firewall. A firewall is always going to be helpful. Have I missed one? Hang on. Have I missed a question? I've missed a question. We'll go back slightly. I missed a question. Identify 3 types of malware that could be installed. So there's spyware, viruses, Trojan horses, and again they've got EG. So if you come up with one that isn't on this list, they have to give you a mark for it if it's a valid malware. So they've got a virus, worm, Trojan horse, spyware, adware, and ransomware. And then back to the final question, part C, give 2 security solutions that could be used to help prevent the brute force attack being successful. So I always say firewall is quite a good one. They've basically listed almost everything that is any kind of security mechanism. 2-step or 2-factor authentication. So that means that if they get in with the password, they send a code to you or your device, and you have to put that in. Biometrics, firewall, proxy server, strong complex passwords. So yeah, the easier to guess password, the more likely they're going to get in. Setting a limit for login attempts. So that's what Apple do. Don't know about Android, but if you try and get onto an Apple phone, you get about 3 goes, and then it gives you a minute before you can try again, and then it's like 30 minutes, and then it just goes up and up until it locks the phone. So that's a really good way to stop a brute force attack. You can use drop down boxes or request for partial entry of password. So yeah, that's a really good way, actually, requesting for partial entry, because if you've got spyware on a computer, then that's going to help confuse the people who have put spyware onto your computer. Okay, so we've got a bit further today. That went slightly smoother than the last time. So thank you for your patience, everybody, and hopefully this will stay a bit more stable. So there's only one bit where it went a bit haywire. All right, so good to see you, and I hope that was helpful. Don't forget to I'm going to put the next date. So the next one's going to be next Wednesday. I can't do next Thursday because I'm out, but it'll be Wednesday and Friday next week, and we're just going to do the same. We're just going to finish off this paper, and then we'll start on the paper 2, and we'll just keep doing that again and again. All right, so take care, everybody, and see you soon.